the side effect on keeping 1.5 within reach in order to avoid the crossing of tipping points in the climate system. I know it's been a pretty busy week and there's a lot going on, so especially as it relates to the IPCC and currently still going on the GST. So we really thank you all for coming while we know that everybody's stretched quite thin. So while the IPCC Working Group 3 report has clearly articulated that limiting global warming to 1.5 is feasible, the emission gap remains at large, 29 gigatons of carbon dioxide equivalent in 2030. And we're in an interconnected process. Mitigation ambition sets the scale of adaptation needs, and adaptation efforts will be futile unless emissions are reduced, with the consequences of inaction being exponential increase in loss and damage. It's clear that keeping temperature increase to 1.5 will also prevent irreversibilities in the climate system, with potential consequences for livelihoods, food security, and health. There has recently been some discussions on this, obviously, within the last few days in the UNFCCC process with the special events on the IPCC Working Group 2 and 3. So today, we have a very distinguished panel of presenters and discussants. Ambassador Perrez will first provide us with some scene-setting remarks on the political context we're in with the UNFCCC and the IPCC, specifically the science policy interface with 1.5 goal and the role of the IPCC in that. Then Professor Stocker will provide a presentation on why we're really here, the proposal for an IPCC Special Report on climate and tipping points and their implications for habitability and resources in the upcoming framework of IPCC's 7th assessment cycle. Then we'll be followed by a presentation online by Professor Engelbrecht. I think I might have butchered your name, so I entirely apologize, who will speak to examples from some crossing the thresholds in the climate system, societal and economic and environmental consequences from a country's perspective in South Africa. Last but not least, my colleagues, Dr. Carl Schleussner and Claire Fyson will outline what is required to keep 1.5 within reach, diving into 1.5 compatible national pathways and sectoral transformations. And so without any further delay, Ambassador is the head of the Swiss delegation to the UNFCCC and Switzerland's ambassador for environment. Over to you.
Thanks a lot, Claire, and thanks to all of you for coming to this side event, despite the heavy agenda. As you were saying, I was just rushing out from the first technical dialogue, but I think it is an important event. Let me just begin with the number 419.69 ppm. That is the level of CO2 today. This level was last seen around 4 million years ago, in a Pliocene warm period when temperatures were up to 3 degrees higher than today. And another number, 7 meters. That's the equivalent of the global sea level rise that the Green Iceland shed holds. In the Pliocene warm period, the Green Iceland shed was almost lost entirely. Once the ice is lost, it requires levels of CO2 half of the current levels and orbital configurations favorable for ice to grow, taking up multiple thousands of years. This can serve as an analog for the future and give us an indication of what it means to cross climate thresholds. Politicians, economists, and even some natural scientists have tended to assume that tipping points in the Earth systems, such as the loss of the Greenland ice sheet, the shift of the African monsoon, or the dieback of the Amazon forests, are of low probability and little understood. Yet evidence is mounting that these events could be more likely than ever thought. By crossing a tipping point, the Earth is entering a new stage of climate regime, which is irreversible, at least for a very long time, and similar to the case in the Pliocene warm period. The IPCC introduced the idea of the tipping points 2 decades ago. At this time, these large-scale discontinuities in the climate system were considered likely only if global warming exceeds 5 degrees Celsius above pre-industrial level. However, new information suggests that tipping points could be exceeded even between 1 and 2 degrees Celsius of warming. An example for such low thresholds are the bleaching of corals. We can already observe that oceans' heat waves have led to the loss of half of the shallow water corals on Australia's Great Barrier Reef. A staggering 99% of tropical corals are projected to be lost if the global average temperature rises by only 2 degrees Celsius. This would represent a profound loss of marine biodiversity and human livelihood. With the loss of the Greenland ice sheet in the Pliocene warm period, the world crossed the climate tipping point and entered into a new climate regime. Understanding tipping point is highly relevant. First, the climate biosphere system is interconnected. It is a global issue. Crossing a particular tipping point will lead to feedbacks, cascading effects to the changes elsewhere on the globe, taking us to a different climate regime. The 7 meters of Greenland ice sheet melt not only leads to a significant sea level rise, it triggers the slowdown of the Atlantic Ocean current and can lead to a potential collapse of the African monsoon. Professor Stocker will provide more information on this. Second, it will have significant social and economic consequences. On these consequences, we will hear more from our distinguished panel on how societies and economies will be and are already impacted once we cross certain thresholds. For example, the shift of the African and Indian monsoon can lead to droughts and decreased agriculture production, hence putting many at risk. Given the highly interconnected nature of tipping points and given the far-reaching consequences of humankind, we need a comprehensive understanding of the tipping points and their implications. Understanding tipping points is highly policy relevant. The IPCC is the right authority and delivers the quality of such a report. Therefore, Switzerland sees it pertinent to call for a special report by the IPCC on the new cycle that starts by 2023 and ready for the second global stocktake. We ask governments and stakeholders to sign up and to join our proposal. The first step would be to have at COP27 to mandate the IPCC to undertake such an assessment, which, as indicated, will be highly relevant for the policies on mitigation, adaptation and financing, and we think that's exactly what we need, the policy relevant information from the IPCC of such a critical event as such a critical thing like the tipping points. Thank you very much, and with this I hand over.
Thank you, Ambassador, for outlining some of those key pieces as we look towards the next presentation. Professor Thomas Stocker is a professor of climate and environmental physics at the Physics Institute of the University of Bern. He's also the president of the Center for Climate Research. I'm going to hand you the mic if you want to.
Ladies and gentlemen, thank you very much. It's good to be back here. I spent quite a bit of my time more than 10 years ago in this building. So thank you very much for listening to the Swiss proposal of a special report in the next IPCC cycle on this very important topic of tipping points. I show here figure 1 of the technical summary of the Working Group 1 contribution to the 6th assessment report. You see on the top the 60 million year evolution of the carbon dioxide concentration in the atmosphere, the most important greenhouse gas after water vapor. Today we have a concentration of 421 ppm, and you can put that into a context of the last 60 million years. The projections that were used and the scenarios by IPCC look at the concentration that may reach actually levels of those 60 million years ago. Levels, therefore, the climate system hasn't seen in a very, very long time, in particular, not during the time humans and ecosystems whose services we are using have developed. The temperature at the same time looks like this. You see that we are gradually coming down from the hothouse into the cycle of the ice ages during the last 800,000 years, and on we go in the scenarios from strong mitigation scenarios which are Paris compatible to business as usual scenarios which end up with a very high temperature. It would be surprising, wouldn't it, if tipping points would not occur in such high emission scenarios. Let's go on here. Okay. These are the worlds as simulated by the CMIP 6 effort. The CMIP 6 effort here with many models that show that at the year 2300, the world looks more similar to the early Eocene than anything that we have experienced in the past millennia. Tipping points actually have occurred frequently during the last ice age. This is sort of the poster child of tipping points, where you see a series of abrupt warm events, cooling events during the last ice age, so-called Donskar-Döschger events, which have global implications, as you can see from the red curve, which is the temperature reconstruction from Antarctica. Now, going more into the details, research over the last 20 years has showed that there are many elements that are able, in principle, to show and demonstrate tipping. This is due to nonlinear processes in the interaction, the physical, but also the biogeochemical, and the interaction with the biosphere. Take, for example, the Greenland ice sheet that has a tipping point somewhere between 1.5 and 4.5 degrees Celsius as per AR5. These estimates have been revised in AR6, but it's sort of a knowledge that has not yet received enough attention and is certainly not at the level that is robust enough for policymakers. At the same time, we have Atlantic meridional overturning, a process that has been investigated over the last 25 years, also an element that can have global repercussions. For people and populations, as well as ecosystems, I consider possible tipping points of the monsoon systems as most dangerous to humanity, and these are indicated here as well. With regard to sea level and potential high sea level rise, tipping points in Antarctica may actually be crossed, and with implications that need to be assessed. I just give you a few examples where the actual science stands here. A result a couple of years ago that demonstrates in two different climate models, so-called fingerprints for a collapse of the Atlantic meridional overturning circulation. We should understand this is not a collapse from one decade to the next. It's a slow process, but it may actually have irreversibility built into the system. At the same time, we now have long-term observations, but not long enough to actually determine whether a tipping point will be approached or even reached within the 21st century. Here you see the rapid AMOC array that takes data and direct observations since 2004. With respect to the question whether what we see in these data is actually natural variability or is already on the pathway towards a collapse of the AMOC, this is a recent study that argues for natural variability. This is just to illustrate that the science is really fluid at this point in time, where a consensus in many of these tipping elements has not yet been reached. An assessment report would really put down the scientists on a path to find consensus where consensus is possible, and also be very explicit where gaps in the research and the understanding of tipping points still are present. Another example is the mass balance of the Greenland ice sheet, as we have now excellent knowledge about its fate. You see here an accelerating loss of mass in Greenland, but also in Antarctica, as indicated by the red curve. The acceleration is the thing that really puts scientists on the watch as to the possibility of approaching a tipping point in certain parts of these ice sheets. One example is the Pine Island Glacier that has in it a tipping element, so-called marine ice sheet instability, that may be triggered in the next few decades. Some researchers say it's already on the path of tipping. Another study here, and you see these are studies not older than 2 years, shows observations in the symbols and the open symbols, then model simulations. That study would suggest that luckily that Pine Island Glacier is actually a stable system, a self-stabilizing system, and a tipping point may not be reached. But again, studies are not unequivocal on these issues, and I think a special report would really make people think very deeply what are the processes that we see that may be at risk towards a tipping point. Tipping points are usually discussed very controversially in the media. They regularly catch attention because they are framed as something dangerous, unexpected, and therefore the headlines that you see here in these little clips are not really speaking of a coherent and consistent picture. Global research programs have also started to focus on tipping points, and therefore that's always a prerequisite of a special report, that there is a body of research that can actually be assessed in the IPCC assessment cycle. And I think personally, given my experience in IPCC since the third assessment report, the science is now mature to actually embark on an assessment. That's without prejudging any outcome of it. For example, here, a long-standing program of Future Earth is focusing on tipping points, but also the WCRP, which is responsible for the CMIP efforts that are the basis of all the projections in IPCC since its inception, has a lighthouse activity called Safe Landing Climates, in which tipping points are addressed. Also, a discussion series has been launched last year that brings ongoing research to the focus of that community. Let's now turn to IPCC. How did we address, since 2001, surprises in the climate system? That was actually the terminology in 2001 third assessment report, surprises in the climate system. They were framed as unexpected events, abrupt climate change, motivated by the knowledge then on the paleoclimate record. More specifically in AR4, Atlantic meridional overturning came into the focus, and the polar ice sheet, again, which is a long-standing topic in glaciology, whether or not these ice sheets and ice streams are stable. Tipping points, irreversible changes in all climate system components for the first time in AR5, and also a reach out to Working Group 2, which I find particularly important that the working group focusing on impacts takes on that topic, because that is ultimately what concerns people. In AR6 now, finally, a cross-chapter box in chapter 12 actually lists 14 reasons of concern. I will not read down the list here, but it's very interesting that within 20 years of research, this list has become longer and longer. The technical summary contains a box on irreversibility, tipping points, and abrupt changes. And it's likely these red-marked elements that are particularly vulnerable to high emission scenarios and large warming and ensuing changes in the hydrological cycle, such as the Amazon forest system, the ice sheets, sea level rise as an element that concerns many hundreds of millions of people who live around the coastal areas, ocean circulation, permafrost, carbon, and again, global monsoon systems, which directly affect many, many millions of people. Therefore, It is my view, and it is Switzerland's proposal, that a special report in AR7 should be commissioned by the IPCC. It would certainly bring a consensus in this contentious issue, which is necessary for policymakers to make science-based decisions on a topic that they primarily read about in the media in controversial ways. This would be the first time an opportunity to go really in depth on this topic. We have also thought about possible contents, but of course this is only one of many inputs that may be given towards a scoping exercise in IPCC, should IPCC decide to go for a special report on climate tipping points. We clearly see tipping points in natural system. We see them in human systems as well. Working Group 3 is particularly addressed here. And what should be an emphasis in these tipping point topics are three things: regional impacts, because they directly speak to people and ecosystems in various parts of the world. Scenarios, this is still an open gap, that scenarios do not involve tipping, and therefore integrated assessment models are not able at the point here to address these processes. And economics. I'm personally very interested to see economic model taking on that topic and informing us about losses and damages and the dollar signs next to them. In conclusion, let me summarize very quickly. Tipping elements in AR6 are clear reasons of concerns. You have seen the list there. Their global and regional impacts pose key risks for humans and ecosystems alike. A comprehensive scientific assessment of tipping points and their regional impacts is missing. There's a true gap that could be closed in the 7th assessment cycle of the IPCC, and that exercise would also provide new scenarios for models that are then available to inform policymakers. Therefore, we would call for a cross-working group IPCC special report. It's important that all three working groups are involved, deeply involved in the compilation and the preparation of such a report. And with that, I'm closing, and thank you for your attention on this matter. Thank you very much.
Thank you very much, Professor, for those insights and some relatively scary messages, but ones that we clearly need to unpack and discuss a bit further. And so with that, we are moving to Professor Francois Engelbrecht online, who is the Director and Professor of Climatology at the Global Change Institute in the University of Witwatersrand, South Africa. I believe he's online.
Good evening, ladies and gentlemen. Thank you very much, Jay, for welcoming me. Thank you also to Professor Stocker and Sebastian Koenig for the invitation and all the arrangements to get me joining you tonight all the way from Pretoria in South Africa. Of course, I would have loved to be with yourselves there in Bonn, but I'm still very grateful for the opportunity to share with you thoughts on the possibility of regional tipping points that may await us in the near future in many parts of the world. But I will give some very specific and concrete examples from the Southern African region. Let me start by just showing two slides from the IPCC Special Report, Assessment Report 6 specifically, Chapter 4, just to set the global context of these regional tipping points I would like to briefly talk about tonight. So if we look at projected patterns of regional temperature change as a function of the level of global warming, then we can all see, of course, very clearly that there are some parts of the world that are warming up substantially faster than the global average temperature. Now, this is where the analysis of regional tipping points in the Southern African region start. If you look at the Southern Hemisphere, one in fact finds a high rate of temperature increase in the Southern African subtropics. In fact, in Botswana, the recorded temperature increase, the rate of temperature increase over the last 5 decades is substantially more than 2 degrees Celsius per century. Some weather stations, in fact, record a rate of temperature increase of about 4 degrees Celsius per century, a staggering increase. And in these projections, you can also see that in the Southern Hemisphere, this part of Southern Africa is one of the Southern Hemisphere regions that is warming up the fastest, perhaps even faster than over some of the Antarctic regions to the south. Now, the next important reason why we should look at the Southern African region not only as a climate change hotspot, but also as a region in which regional tipping points may occur, is because of the projected changes in precipitation. This region is one of the few land masses of the world that are projected to become generally drier as the world warms up. And that means that Southern Africa, that is already a warm and dry region naturally, as many of you will know, is now currently warming up at a drastic rate. It's projected to warm drastically. And at the same time, it is likely to become generally drier. This is the main reason why the IPCC in the special report in 2018, the report on global warming of 1.5 degrees Celsius, identified Southern Africa as a climate change hotspot. Because, ladies and gentlemen, it's of course not difficult to think why. If a region that is warm and dry becomes drastically warmer and drier, the options for adaptation are greatly limited. And as an African scientist and having lived in this region for all my life, I have become gravely concerned in recent years that we may already be, in fact, seeing the first signs of a climate regime shift in Southern Africa, a tipping point that will completely change the way in which we live in Southern Africa. Let me now make that point by some examples. Firstly, if we should zoom in to any region in the Southern African subtropics, almost any location, except maybe the Lesotho Drakensberg of South Africa, the steep mountains to the east. This is the type of graph that one finds when one plots annual precipitation anomalies on the x-axis and temperature anomalies on the y-axis over time. So we are looking here at annual temperature and rainfall anomalies calculated with respect to the period 1961 to 1990. And the colors help us to move over time in the graphic. So those purple and blue dots, they represent the period 1961 to 2005. So I trust you can see what a graph means. It just simply means that there's climate variability. Some years are cool, and they are usually a little bit wetter than normal. And other years are a bit dry and warmer. So there's natural variability in the system. This specific graph, by the way, is for the Cape Town region, specifically the Theewaterskloof region, which is the big catchment that supplies the city of Cape Town with water. But as we then move through in time into the middle of the century with those dark yellow dots, and then towards the end of the century in the orange and red dots, you can see how this climate regime of the southwestern tip of South Africa is projected to change completely into something completely different. A future regime that is not only drastically warmer than the present day, almost every single year is also drier. than the present day. And as I've said, this type of behavior of such a delta precipitation, delta temperature plot, we see everywhere in the Southern African subtropics. Now, many of you will know about the Cape Town Day Zero drought that occurred from 2015 to 17. The city almost ran out of water because of a drought that lasted for 3 years. It was a real surprise. Perhaps it should not have been a surprise, but it surprised South Africans at the time. This graphic is a grave projection of a low mitigation future. It tells us that Cape Town may have to frequently battle these multi-year droughts. And I think already tonight I can make a statement that the city of Cape Town likely needs a new water resource to keep on growing sustainably in a warmer world. But we need probabilistic estimates of these types of multi-year droughts occurring more frequently and in unprecedented ways. Right now, it's a major and critical science gap for South Africa. But from the background of this type of future combined temperature and precipitation behavior holding across Southern Africa, let me just give 4 examples briefly of tipping points we need to study in more detail for this region. The first is then the possibility of what we've come to know or to call day zero droughts in South Africa. I think the biggest single risk that the South African economy faces today from climate change is the possibility of such a day zero drought occurring in the Johannesburg region. This is the Gauteng province of South Africa. We have 15 million people living here. Almost all our industries are in the Gauteng province. And the region critically depends on a specific region in eastern South Africa, the so-called mega dam region, to get its water from. Now, in 2015-16, we had an unprecedented drought, the biggest drought in terms of midsummer rainfall recorded since we have observations, biggest drought in 100 years. And the Vaal Dam that directly supplies Johannesburg, its level fell to below 25%. Should it have fallen to below 20%, we would have had a major water crisis because the water cannot then be pumped uphill all the way to Johannesburg. So we came critically close to a major water crisis in the Gauteng province back in 2016. And as I've mentioned, a generally drier and drastically warmer future for Southern Africa will increase this risk. But right now, we don't have probabilistic estimates of the likelihood of such a drought occurring. Remember, it will be unprecedented. There has never been such a drought. But qualitatively, the science and what happened in 2016 is telling us it's possible. We need a far more coordinated research effort to quantify this risk as a regional tipping point. Then the second example, I've mentioned Botswana. During that major drought, Botswana lost 40% of its cattle. Now, those of you who know this beautiful and wonderful country, about 70% of the people in Botswana still has some dependence on cattle. It was a devastating event. At the same time, the maize crop in South Africa was 40% lower than in the previous year, the previous season. So are we on the verge of seeing a new type of drought in Southern Africa, one that lasts for 4 to 5 years, accompanied by major heat waves of unprecedented intensity that kill tens of thousands of cattle, as it did in 2015-16, and that also impact significantly on the maize crop? So in the special report in 2018, the IPCC assessed that this threshold may be reached at 3 degrees Celsius of global warming. But I think if we take into account the socioeconomic aspects, how many of these droughts can a subsistence farmer in Botswana or in the Limpopo province of South Africa or in Zimbabwe survive before he or she has to give up on farming? I think if we take into account the social elements, this tipping point is awaiting us far nearer in the future than at 3 degrees Celsius of global warming. Third example, unprecedented heat waves. It's a major risk in Southern Africa, but yet not substantially quantified or appreciated. We all know about the Pacific Northwest heat wave in June last year. I think the estimates in the end were that more than 500 people died in parts of Canada and the northwestern states of the US. Here, where I live in Southern Africa, almost nobody has air conditioning. We have very large informal settlements where people live without air conditioning, and sometimes they don't have easy access to water, to clean and cool water. That, of course, is life-threatening when a major heat wave strikes. And that, I think the science tells us that we can expect unprecedented heat waves in this region already the next 10 years. I'm deeply concerned that we will for the first time have a heat wave impacting on Southern Africa that can kill thousands of people as heat waves become more and more prevalent in a warmer world. It's yet another very clear danger, but once again, we need to quantify how close into the future this risk awaits us. And then finally, something completely different. In the IPCC assessment report, regional fact sheets for Southern Africa, there are three main messages. It's drastic warming, it's general drying, but then in parts of Eastern South Africa, despite the general drying trend, there's also the likelihood of increases in intense precipitation events. This can already be detected in the region the IPCC has just assessed. I think there's also the possibility of the climate regime shifting, of a shift in climate to a new regime where intense tropical cyclones can, for the very first time, propagate as far south as Maputo in Mozambique or even northeastern South Africa. The satellite picture shows the landfall of Cyclone Idai in March 2019, a Category 4 hurricane just before it made landfall. That was its intensity. It was unprecedented. It killed more than 1,000 people in Southern Africa. This, ladies and gentlemen, is the largest flood disaster that has been recorded in the history of Africa south of the equator, and it occurred just 3 years ago. If we look at the IPCC assessment of the likelihood of increases in intense tropical cyclones in a warmer world, we should be gravely concerned. In Maputo to the south and in the Limpopo province of South Africa, there are large informal settlements. A Category 5 hurricane is not survivable, just in terms of the effects of wind speeds on informal housing. And then we are not even thinking of an unprecedented storm surge and flooding in the Limpopo River Valley and in Maputo. To conclude on a more positive note, these are major risks. We do need a probabilistic understanding of the likelihood of these risks already in the near term. Given my IPCC authorship, I'm not currently formally linked to the South African negotiations team, but speaking to our colleagues that are in the delegation, I suspect that Switzerland will have very strong support from South Africa in terms of a special report focusing on tipping points. And of course, what will be important across Africa is to understand the possibility of regional regime shifts. Unprecedented events that due to these regime shifts can be classified as regional tipping points. That's also the positive part of the message. If we can develop this probabilistic understanding, and we all know that the special report will have a major effect on boosting research in this field, that will help us to at least be, to some extent, be prepared for these major changes that I think likely awaits us in Southern Africa. Thank you. Thank you, Chair. Thank you, colleagues.
Thank you. Thank you very much, Professor, for outlining some of those regional situations and potential case studies, especially the point of the possibility of Cape Town needing an entirely new source of water. I very much appreciate also the catastrophic impacts of Category 5 hurricanes, myself being from Antigua and Barbuda, so not to be underestimated there. So now moving on to a bit of a longer presentation, but I'm going to ask you guys to noting the time. We have Carl, who is, I say Carl, is the head of climate science and impacts, and Claire Fyson is the team lead on mitigation pathways analysis, both with climate analytics. Claire and Carl, or Carl first, and then Claire, over to you.
Yeah, thank you. Can you pass me the pointer? Yeah, thank you all. I think I'll make a way out to this side. So good evening, also from our side, and we've heard a lot about the risks from climate tipping points and the risks of also them emerging in the very near term, and this links very strongly to the ambition to limit warming to 1.5 degrees, because this would bring down climate risks in the very near term, and we want to shed some light on this in our presentation today that I give together with my colleague Claire. To start us out, I want to talk a little bit about 1.5 degree Paris Agreement compatible pathways. So we do a little bit of a general detour to make us understand what we talk about when we talk about 1.5 degree pathways, and my colleague Claire will then talk about what needs to be done to actually get on such a pathway. Before I dive into the substance matter, I want to just get one thing out of the way, because this has created a lot of media attention and potential confusion in the recent weeks around a press release from WMO that we might reach 1.5 degrees in a single year, probably over the next 5 years. The Paris Agreement 1.5 degree temperature limit and the way it is assessed in the scientific literature as well as in the IPCC reports speaks to a long-term average human-induced warming outcome. That's something different than an individual year, and the IPCC is very, very clear on that a single year above that certain threshold doesn't mean that limit has been reached. It is a worrying sign that we are approaching that threshold, no doubt about that, but it doesn't mean we will be at 1.5 in just 5 years' time. That's not what it means. With that out of the way, we can talk about pathways that would limit warming to 1.5 degrees or keep 1.5 degrees within reach. The most recent IPCC Working Group 3 assessment report provides a range of different pathways. In total, more than 1,000 pathways have been assessed and categorized according to their warming outcome towards the end of the century. The lowest categories in those pathways that you see at the very bottom, C1 to C3, are defined in relation to 1.5 degrees, to their probabilities of keeping warming to below 1.5 degrees or 2 degrees, respectively. One aspect that is important to highlight in these bar graphs that you see there are that you see a thick median line and you see a very substantial uncertainty range around this. And then when you look at those definitions of those pathways, you always see a percentage probability statement connected to the categorization of those pathways. And this is very important and something I want to unpack a little bit more, because we all got very accustomed to shorthands of talking about 1.5 or 2 degree pathways or whatever we might talk about, but we tend to forget that there are probabilities connected to it. And for example, this C3 category has a mere 2 in 3 chance of limiting warming to below 2 degrees. In fact, it has about between 5 and 10% chance to see a warming of 2.5 degrees under such an emission pathway. And that's something we need to keep in mind, in particular when we talk about it in the context of tipping points, where we know that we want to hedge against potential high impact outcomes of different emission trajectories. So let's look at this in a little bit more detail, and we might discover that this perceived bifurcation of 1.5 or 2 degrees might actually be a slight misleading way of framing the question. So let's look into what the Paris Agreement says actually in terms of pathways that could be deemed compatible with the Paris Agreement. And we defined 3 different criteria in a publication that's forthcoming on criteria that we established based on Article 2.1, the long-term temperature goal, as well as Article 4, which is the long-term mitigation goal. And the first criterion, the pursuing efforts of limiting temperature increase to 1.5, we would relate to a definition that the IPCC has brought forward, so to pathways that are not likely to exceed 1.5. This is the low and no overshoot category, so the best estimate would be that there might be an overshoot of maximum 0.1 degrees above the 1.5 degree limit before temperatures would come down below 1.5 degrees again. What is important to highlight is that there are also pathways, a very small number, but there are existing pathways that would not show an exceedance of 1.5 degrees in the best estimate. The second criterion links to the well below 2 degree hold warming to well below 2 degree language. And what is important to highlight here is that the Cancun goal of the UNFCCC, so the pre-Paris Agreement language, referred to below 2 degrees, holding warming to below 2 degrees. A process was conducted under the UNFCCC based on the IPCC Fifth Assessment Report, and I'm sure Thomas Stocker would remember this process very, very well, the periodic review, and the IPCC has provided ample input into this. And the report found that 2 degrees cannot be considered safe. So the report of the Structured Expert Dialect, which is currently ongoing. And this has critically informed the strengthening of that language to well below 2 degrees. Well, if I tell my child to stay well away from a cliff, I don't expect necessarily a 1/3 probability of her jumping down. Oh, I won't hope so. So I do probably want to have a good chance. In IPCC terminology, if we go from below to interpreted as a likely 67% chance to the next IPCC level that we have available, that's very likely. That's a 90% chance of staying below 2 degrees. That's one possible way to interpret the well below 2 language. So we may adopt this here. And the fourth criterion is very clearly linked to achieving net zero greenhouse gas emissions, which would lead, once achieved, to long-term declining temperatures, thereby establishing 1.5 degrees as the long-term upper limit if temperatures are on a downward trajectory. With that established, now let's look at the probability of exceeding 2 degrees versus 1.5 degrees in pathways from the IPCC Working Group 3. So the 2 degree probability is on the x-axis here, the 1.5 degree probability is on the y-axis, and let's just frame this around the criteria that we have established. So the orange bar gives you, in the 1.5 degree space, a higher than 33% chance of not exceeding that level, and the purple bar gives you a below 2 degree chance of 90%. So these are the two criteria that we have established, one for pursuing efforts to limit warming to 1.5 degrees, the other one for holding warming to well below 2 degrees. And now if we map the pathways in the space, you actually do see that pathways that are C1 pathways, so fall into the 1.5 degree category, also have an almost 90% and several of them higher chance of limiting warming to well below 2 degrees with a very likely chance. So there's a direct interconnection between these two elements of the Paris Agreement. There's not a way to achieve 2 degrees or 1.5 degrees. In very concrete terms, you could say if you want to be sure to keep warming or hold warming to well below 2 degrees, what you need to aim for are the 1.5 degree pathway category of the IPCC. So I think that's an important dimension to understand, in particular when we deal with highly uncertain systems like tipping points that we learned about in the two previous presentations. We should keep these probabilities in mind and should not use just shorthands that may give a misleading impression of what the choices actually really are in the mitigation space. So we do have a number of pathways in the IPCC report that we can consider fully Paris Agreement compatible. And we will learn more about those pathways from my colleague Claire in a second. I want to talk in my second part of my presentation about a pathway that unfortunately, or a message that unfortunately is not necessarily Paris Agreement compatible, but has created a lot of headlines in the recent weeks and months as well. And that's the finding that under very optimistic assumptions, all the pledges by parties or promises by parties over the 21st century in terms of their climate commitments would lead to an end-of-century warming outcome of 1.8 degrees. So let's unpack that a little bit. Here's where this comes from. This is the global temperature projections from the Climate Action Tracker. There have been other publications showing this as well, a recent Nature publication, for example, diving down on this particular topic. But we do see current policies and actions still lead us to a solid 2.7 degrees of warming by the end of the century. So what this is, it's a most optimistic scenario, assuming all announced net zero targets are going to be implemented. What is important to understand about this is that this is a pathway that doesn't assume any additional action in this critical decade. And this has several severe implications. So you do see this pathway up there, basically being much more closely aligned to the current policies and actions, and certainly to the on the NDC pathway line. And it has a major ambition gap to what would be 1.5 to be consistent. And what we understand very well from the IPCC and other sources is that such a pathway would put 1.5 degrees firmly out of reach. So while it sounds like a great achievement to go from 2.4 to 1.8, the delay in action in this critical decade would mean 1.5 degrees is out of the window. So that's the first thing that's not good about this pathway. The second is that it's not at all credible. we do know what cost-effective pathways look like to achieve those net zero targets that countries have put forward, and delaying action is not one of them. In many ways, you could say it is a pathway where you say, well, we all assume climate change is the most important thing we need to do, so let's wait 8 years and then get really going. So the emission decline that you see after 2030 is very, very steep. For some countries, it's even steeper than it would be under a least cost 1.5 degree pathway. So whether or not these commitments may be actually achieved is highly doubtful. And you don't want to bet your money necessarily on that, because you could easily wake up in a 2.5 degree world. And the third part I want to unpack a little bit more is the failure to avoid climate impacts in the near term. And Francois has talked about the need for bringing down climate risks in the very near term, and the very substantial risks that, for example, are being faced in the South African region. So if you look at this a little bit more, and I just want to conclude my presentation just kind of showing pathways from the Working Group 3 report that they identified as illustrative mitigation pathways. And never mind the details, they have pathways that map to the space that we want to talk about. So we have a range of 1.5 degree pathways, which are on the bottom right, and you do see they are characterized by very steep emission declines in this critical decade. And you have a pathway that they call gradual strengthening, which is the red one at the top right. And this pathway shows increasing emissions over this decade and then rapid declines. And what we can do is we can compare the warming rates in the near term between these different pathways. And we've done so on the project Constrain, and Horizon 2020 project Constrain, where we compared the warming rates in the 2030s, the 2040s, and the 2020s, the 2030s, and the 2040s. And this is a bit of a difficult graph to read. But if you look at the three scenarios to the left, so the bars go warming rate in the 2020s, to the warming rate in the 2030s, to the warming rate in the 2040s, compared to the red one, which is the gradual strengthening pathway. And what you do see is, under 1.5 degrees, already in the 2030s, we would slow down the central estimate for the rate of global temperature increase by about 50%. So we would slow down warming, and we would slow down, therefore, also the emergence of regional impacts and all the risks that we are talking about. And in the 2040s, we would halt global warming. And in a gradual strengthening pathway, this would not at all be the case. We will not see any substantial slowdown in the continuous warming of this planet until around mid-century, and not halt warming until well beyond that point. So there are very clear near-term benefits from stringent 1.5 degree compatible mitigation, and what is required to get us on such a trajectory, my colleague Claire will present to you now.
Great, thank you, Carl. So hopefully you are now all convinced that we need to close the 2030 emissions gap. So the next question is, how do we do that? It's a complicated question, and I'm afraid I don't have all the answers, but I'll try with some. So first of all, we know that the energy transition has started. The key part of keeping warming to 1.5 is, of course, to decarbonize our energy system. And with renewable costs plummeting, we are underway, and there is increasing pressure to get that key fossil fuel, coal, out of the power system. And we've seen this with the UN Secretary General making calls for countries to phase out coal as soon as possible by 2030 in OECD countries and 2040 in the rest of the world. We've also finally seen this acknowledged in the COP decisions in the Glasgow Climate Pact last year. But there's an elephant in the room, because coal isn't the only fossil fuel that we have to worry about, and that is fossil gas. And as a quick teaser, we actually have a report coming out on fossil gas in the power system next week, so watch out for that. What we did is we looked at what happens to fossil gas power generation in 1.5 degree pathways. And what we see is that it really cannot be a transition fuel, as some people suggest that it can be. And that's because it can't last long in the electricity system after coal. So we see across world regions a phase out of gas power generation around 5 to 10 years at most after coal is phased out. And that means that any investments in fossil gas power generation in this decade carry a significant risk of creating stranded assets or risk locking out 1.5 degrees. So watch out for that next week. But I actually wanted to focus, instead of on the global level benchmarks, which are important for providing a direction of travel, I really wanted to talk about what happens at the national level, because that's really important for helping governments and the wider civil society to set and evaluate targets, to set and evaluate NDCs, long-term strategies, and to put in place the right sectoral policies to get us on track for 1.5 degrees. And we have developed a tool called the 1.5 National Pathway Explorer. The key is in the name. It provides pathways at the national level for 1.5 degrees, and also provides benchmarks such as coal and gas phase-out dates for different countries. How do we do that? Well, we start out with global, technically and economically feasible pathways, such as those assessed by the IPCC. We select those that are compatible with the Paris Agreement, but that also meet certain sustainability constraints, for example, that don't use too much bioenergy. And then we downscale these from the regional to the national level to provide various benchmarks. And we look at a series of illustrative pathways. Different pathways get to 1.5 in different ways, so we try to map out what these different approaches are for different countries. We have this now for a number of countries, so check out the website. There's over 40 countries with profiles now already online and more still to come. And I want to just talk quickly through 3 examples. You'll see here that I've noted the climate action trackers rating for these countries. All of them are off track, some of them very off track, and all of them have significant scope to strengthen their NDCs, as governments agreed to in Glasgow last year, to strengthen their NDCs in line with 1.5. So first of all, Indonesia. Now, when we look at Indonesia's emissions, it's really a story of coal and deforestation. So almost 2/3 of Indonesia's power system comes from coal, and unfortunately the government seems to be planning to lock in coal dependency into the long term. You can see now in the plot at the bottom, emissions from land use change are really the dominant emission source in Indonesia. And while there has been good progress in reducing tree cover loss over the last few years, there is still a worrying amount of commodity-driven deforestation. And while the country has really significant renewables potential, it's not deploying that quickly enough. So what does a 1.5 degree pathway look like for Indonesia? Well, you can see in this graph, this is one of the first graphs that you'd come to on our website. The blue lines show the range of 1.5 compatible pathways for Indonesia, with a median line highlighted in blue. And if you look at the yellow dots right at the top, I don't think I have a laser, but if you look at the yellow dots, you can see where Indonesia's current NDCs are. So they allow for about 100% increase in emissions from 2015 levels. The pink line shows, meanwhile, where its current policies are set to take Indonesia. So you can see that it's already set to really well exceed the emissions reductions in its NDC, but it would need to go even further to close the emissions gap, to close that ambition gap and get to 1.5. Of course, to do that, Indonesia would need support from developed countries, but clearly there's a long way to go. And I should note that these pathways are focused on emissions excluding the land sector, because we separate out emissions from land versus emissions from fossil fuels. There will be land use pathways coming shortly onto the tool, but of course, in the case of Indonesia, we need to see deforestation falling rapidly. I won't go into this in detail in the interest of time, but there's also information at the sector level for all of the countries. So you can see here, for example, in the power sector, across different pathways, all show a really rapid shift to renewables and a rapid phase out of unabated coal and gas in the mid to late 2030s. Now the EU, a very different example. The EU has, unlike Indonesia, which has not yet strengthened its NDC, the EU did strengthen its NDC in 2020. It's now at a crossroads, obviously, with the Russian war in Ukraine and the ongoing energy crisis. The EU is looking at new policies, for example, to increase the share of renewables in its energy system and reduce energy consumption. But at the same time, we're seeing mixed messages. It's also planning investment in new fossil gas infrastructure and switching some fossil gas power plants to coal. Some member states are also subsidizing fossil fuel consumption rather than focusing on electrification, strengthening renewable energy, and energy efficiency measures. So a mixed picture. So what do we actually need to see for the EU? Well, we need to see, you can see in the yellow dot there is much closer to the blue line in this case, but still a gap remains, and the EU needs to drop its emissions, excluding land use emissions, to 61 to 70% below 1990 levels, and to phase out coal and fossil gas really quite quickly. Now, the plan that the European Commission has proposed to enhance renewables to 45% could close this gap further. So recent analysis by the Climate Action Tracker showed that this could bring the EU's target to within 4% of a 1.5 compatible range. So clearly there's a big opportunity here for the EU to show leadership in the climate space and to enhance its NDC in line with what was agreed in Glasgow. Finally, Egypt, the COP27 presidency. Now, Egypt is a fossil fuel-powered economy right now. It's heavily reliant on oil and gas. Egypt is responsible for over a third of Africa's fossil gas consumption and 40% of the CO2 emissions from gas in the continent. It has been ramping up production, so it saw a decline in gas production, which led to severe power outages. Production is now picking up, and the government is really emphasizing plans to expand fossil gas exploration, production, and exports. And this is also included in the government's NDC to upgrade fossil fuel power plants and invest in carbon capture and storage. And this risks creating stranded assets in a 1.5 degree world, as well as burdening consumers with very high energy prices. It has made some investments in renewables, and there is significant potential in the country, but these are still dwarfed by fossil fuel investments. And at the moment, Egypt's NDC does not provide a quantified emissions reduction target, which makes it a little bit difficult to assess. And it also hasn't been updated. So we're really looking to Egypt as the COP27 presidency to provide an updated NDC with a quantified emissions reduction target. What would that look like? Well, according to our analysis, this should be a 15 to 33% reduction below 2015 levels by 2030, somewhere on one of those blue lines. And at the sector level, again, you can see on the website for more detail, but this really means no expansion of coal, a phase out of gas power by the late 2030s, and a really rapid expansion of renewables and electrification of end-use sectors. So that was a bit of a whistle-stop tour around a few different countries. Obviously, there's much more on the website, so please take a look if you'd like to understand a bit more about what different countries need to do to limit warming to 1.5. But just to kind of capture all of this information in one slide, so just if you need to remember 4 points from mine and Carl's presentations, it's that stringent action this decade to close the emissions gap is really important for reducing the warming rate in the near term. And we've heard a lot about the dangers of accelerating warming if we don't close that gap. Unfortunately, right now, there is a clear credibility gap between the 2030 targets that governments have put in place and what they're planning in the longer term, which suggests they haven't done the thinking on how to get their emissions down in line with 1.5. There are clear benchmarks for the power system that governments should be thinking about. Look out for our report next week. And the national pathways show that there is a lot of room for improvement for governments to strengthen their NDCs and to bring them in line with 1.5. So no excuses to fall back on that Glasgow Climate Pact. And I've put some useful resources at the bottom there. Thank you.
Thank you, Carl and Claire, for some really key messaging, especially on the last three, our G20 presidency, our COP president, incoming, designate, and that of the EU. So now we're going to move on to the section where you all get to ask questions. Thank you for keeping in. There's been a lot of detailed information coming at you, and so I'm sure that you may wish to unpack some of this. So without further ado, are there any questions from the floor? And if not, I definitely have a few. Yes, at the very back. If you could speak quite loudly.
You need a microphone for
Okay.
I can also just speak really loudly.
We're going to need the mic for recording, having it embedded in the recording. Thank you for holding on. Great. If you could just let us know name and who you're speaking on behalf of.
Hi, my name is John. Hello? I think it's working. All right. Yeah, my name is Jonathan Mock. I'm part of the US delegation, but I'm speaking on behalf of myself. This is just a question. So the presentation we just saw with the downscaling of the national mitigation pathways, how does that downscaling work? Because that sounds like a really useful tool, but on the other hand, how much understanding does that give you of what are abilities for countries to enhance NDCs? How, like, is it done in terms of economic capacity, mitigation potential, equity? What are the considerations that go into that? Thank you.
Thank you for the question. We'll take another one from the floor, if there is. Yes? Here in the middle.
Thank you. My name is Gerrit Hansen. I'm also speaking on behalf of myself. Thank you very much for all these interesting information, also for making this very important link between tipping points and European warming, the risk of crossing two tipping points due to the wrong, say, like too high emission pathways. My question would go to Thomas Stocker. In your presentation, you also listed the human, tipping points in human systems, and I would just like to understand better what exactly you mean by these human system tipping points.
And then maybe one more up here in the front, and then we'll go to the panelists.
Hi, my name is Alina, also speaking on behalf of myself. Thank you for a remarkably interesting presentation. I guess I'm kind of an optimist, or try to be. Do you have any good examples of kind of increasing ambition that helps countries or sectors to be in alignment with the 1.5 target, sort of, because, you know, we can learn from one another. So yeah, that would be my question. Thank you.
Should we take the one behind you as well, and then we'll go to the panel? I know that there was your hand. Thanks.
Thank you, and thanks for the presentations. My name is Jörg Füßler from Infras, and I guess we would be probably the users of such a special report, because we advise governments on adaptation plans and how to prepare for different scenarios. And I think it's quite striking, because I think also there is a bit of paradigm shift I see, because one cannot use these middle of the road scenarios anymore, and needs to look much more at these more extreme scenarios. We are also doing work for the German government where we are explicitly asked to look at high impact scenario, and it's a hugely difficult thing to do, because there is not a lot of reliable data, and such a consensus would be hugely useful. My question goes to Mr. Stocker, because you also work sometimes with politicians, and it's already quite difficult to explain, say, usual scenario work, changes in average temperature, and now you would have a report with, which has some really drastic messages, probably, but the uncertainties are huge, right? You have to say, this could be hell, but I'm not so sure if this happens before I die or before my kids die, right? So that's the question. How will you approach, or would you approach the messaging side of such a report? Thank you.
Thank you, all three really good questions. Claire, you're going to take question one, and then over to you, Professor, and anybody who wants to come forward with good examples of the sector transformations.
Great, thank you. Yeah, good question. So we use different methods for different sectors. The idea is that we have emissions at the macro region level provided by the scenarios themselves. Then we take into account the current situation that each country is in, so its current emissions, its current economic circumstances, and it then follows a projection defined by what's happening at the regional level. But the way that we share out those emissions between countries in the region depends on the sector that we're talking about. So, for example, for some sectors, we use an emissions intensity convergence. I think I don't want to go into too much detail, but actually our resident modeler, Lara, is sitting over there. So if you have more questions and you'd like to know more, then I'd suggest you speak with her. I would say we can't replace bottom-up models, which really take in the nitty-gritty details of a country into account. But the power of this analysis is that it can really draw from what is at the global level consistent with limiting warming to 1.5, and then downscaling so that we know that when we add all of those countries' emissions pathways up together, we do end up with a 1.5 degree world, which is something that is much more difficult to do with a bottom-up approach. And also we can provide emissions pathways for a large number of countries as well. Yeah.
Thank you very much for this interesting question on human tipping points. I think 2 points come into mind which are really relevant for keeping the Paris Agreement targets alive on a human level, and that is the adoption of technological measures and the willingness of people to do that. And I will give you an example of a human tipping point that we've all experienced. And at the same time, the awareness of a problem. And there I give you also an example. Regarding the adoption of technological measures, many of you probably are skiers during winter season. Some of you have started skiing without helmets. If you go on the slopes today, almost everybody wears a helmet. So I think there was a tipping point here where the awareness of a problem and the adoption of a technological measure on a very personal basis has led to a much safer situation. And I think it's important for social scientists and the social scientists community to identify such tipping points in society, but also with individuals, to help keep on the path of 1.5 degrees Celsius. The awareness of the problem, smoking. Who would have said 30 years ago that within very few years smoking is no longer permitted in public spaces? It really went very quickly. To me, this is a social tipping point, and I think it's very instructive to investigate cases, to assess cases where social tipping points can actually help keeping us on track with the emission reductions.
Yeah, thank you. I'll going to respond to the question of Elena. So I think it's a very good question, and I think for first and foremost you will find a big variety in the assessment of countries and their national mitigation ambition in terms of their 1.5 degree compatibility. And I can only encourage you to explore this a little bit, because we cover not just the G20 countries, or the tool doesn't cover not just the G20 countries, but also a large number of developing countries. And you will find quite a number of climate leadership examples also in developing countries, which I think is very important. But I want to highlight one source of optimism for me quite personally, and that's the recent Working Group 3 report, indeed, which includes a bottom-up assessment of sectoral mitigation options for all different sectors and with cost assessments. It's the figure SPM7, it is, I believe. And it shows that we can close the 2030 gap. And with measures that in total would, on average, cost less than $100 per ton of CO2, which is well within reach. It may sound much to you, but this is well within reach in terms of the overall cost of such a transition that we would envision. And what is remarkable is that many of these options, first and foremost, might not cost anything and bring us quite a long way. So half of this could be reduced by options that almost cost nothing or even pay for themselves. So there's enormous mitigation potential out there if you go through the sectors and look at those. And I think I personally was very was very positively surprised to see such a comprehensive database and assessment in terms of what are the sectoral mitigation options and what can be done. And I think there's a much to unpack there also in the context of, for example, the global stocktake that's currently ongoing here, in terms of the findings of the IPCC in that regard. So it's not just kind of that the IPCC established a global gap and what needs to be done, but also very, very much provided a broad portfolio of solutions that you could look into. And if I'm allowed to just add something to the human tipping point, a question from an impact perspective, because I very much agree that the mitigation side and the basically non-linearity and changing human behavior is extremely important if you look into the solution space. But unfortunately, we also need to account for human tipping points on the impact space. So the Working Group 2 report very strongly outlined the limits to adaptation that in some regions may already be reached and increasingly will be reached for warming at 1.5 degrees and above. And what this effectively means is that there need to be very, very drastic measures, responses to loss and damage being taken, such as migration. There might be destabilization of societies. We will have loss of societal stability and many other things. And there will be these are tipping points as well, but just in the wrong direction, so to say. I mean, there's certainly no way to reverse destabilized society in a very quick fashion. So we need to look at these questions very critically. And this is another dimension where the science that's forthcoming is very, very clear that we are not, human societies will not be able to linearly just deal with the problem as it emerges, but we do increasingly see that these limits are very severe and currently many countries are indeed very much constrained to respond to the climate crisis in an adequate fashion.
Perhaps I take the question on extreme events and the extreme scenarios. I think that's a very pertinent question. IPCC was in that precise situation about 10 years ago when the special report on extreme events was being prepared and then published and then communicated. Extreme events as a new concept that you need to communicate details of a probability distribution. And I think looking at this evolution 10 years hence, I think the scientists managed quite well to bring this topic right to the decision makers. And nowadays, people are really used to also look at statistics of extreme events while at the same time not assuming that even if it's very likely that such an extreme event will come tomorrow. So prevention there is a big issue here, and I think that special report on extreme events has not only accelerated the science around extreme events, but also the awareness of policymakers. And I could envisage a similar effect on tipping points, although I see here a much longer time scale. So important topics are pathways towards instability, the exploration and communication of such pathways, which would also lead to some very targeted monitoring efforts. For example, I've mentioned the monitoring of the Atlantic meridional overturning circulation, or monitoring through remote sensing of ice streams and ice sheets that would lead to tipping points that have a very much longer term consequence on the climate system and impacts on regional climate change. So I think it will be difficult to communicate, but I think with the science giving the basis of it, I think it will be doable. And we've done it for the extreme events.
Thank you all for your really good responses. And I appreciate that for that last question, somebody who works in science policy interface communicating something that's a slow onset or over a very long time horizon with a lot of uncertainty is very difficult to communicate, especially to policymakers, let alone politicians. So thanks. Thanks for that. Noting the time, we might have the chance for one more question before we give the floor to you guys to give your last thoughts. Is there any more questions from the floor?
Hello, my name is Gudminder Kaur. I'm from the Norwegian delegation. My question is that in one of the presentations you said that if the global temperature exceeds 1.5 degrees 1 year, that doesn't mean that we have the temperature is 1.5 degrees permanently. For how many years would you say that the temperature should exceed 1.5 degrees before we say that now we have reached 1.5 degrees?
Quite a difficult question given the the space that we're currently in. So Carl, over to you.
No problem. I'm just a bit nervous. I'm sitting next to a former IPCC Working Group 1 chair, and there's very strict ways on how this should be defined and assessed. I'm happy to say we have published a few papers around this question even, and looked at this in a little bit more detail. So if we are at 1.5 degrees long-term average, which we climatologically we would define as a 20-year average or a 30-year average, we would see every other year being warmer than 1.5 degrees. That's the definition of an average, right? This could also be multi-years. Indeed, if you look at dimensions of natural variability, there's no reason why you wouldn't even see a couple of years, 5, 6, 7 years above 1.5 degrees. You can't really say. There are different approaches on how to look at this question. So we also have established scientific methodology on how to identify the human attributable component in the observed warming signal. They match reasonably well, of course, because that's the way we calibrate our approaches, to long-term averages over the historical period. However, they are subject to uncertainties which, ironically or not, are of the scale of about 10 years of current warming rate. So we rate warm currently right now with 0.2 degrees of warming, 0.2 degrees global mean temperature increase per decade. And this is the uncertainty also around approaches of human attributable warming. So in some ways, we are looking into something that me being a physicist would call maybe the Heisenberg problem of temperature targets. We will only know in hindsight whether or not we have crossed a certain warming level. And we would not know 1 year or 2 years later. We would know probably between 5 years and a decade later. So, of course, the closer we come to 1.5 degrees, the more years we might have to expect around that warming level. And this will be indeed, and we've talked about communication challenges, not an easy task. But I think the more important it is to really understand what the long-term temperature goal of the Paris Agreement relates to, because these things will emerge even under pathways that are compatible with a 1.5 degree limit. And it needs to be understood that this cannot be easily directly related.
Oh, maybe just briefly an additional comment or thought. We also have the global carbon budget. And the global carbon budget gives you an indication how close we are of approaching the 1.5. Of course, there are uncertainties. But once the carbon is in the atmosphere, it's very hard to get rid of, as we all know. And so I think it's a very useful additional indicator to inform the world how close or how close beyond we are at 1.5.
Thank you both. And with that, I am not going to try and summarize all of the presentations, but I'm going to give you each 30 seconds to a minute to give any closing points that you want to make or any key takeaways that you think were important to take away from today. Claire, maybe starting with you and then ending with Ambassador.
Yeah, so I think it's crystal clear to me that we really need to get our emissions down. The 1.5, keeping warming to 1.5 is fundamental, and that, of course, all of the actions, they look quite daunting now, but I think, as Carl said, there's a lot of reason for hope because we have the technologies. We know that a lot of them are very cost effective, and I think living through this current energy crisis, you can see that actually a world where we have renewable energy systems and more sustainable land use systems is actually probably quite a nice world to live in, apart from the climate change impacts. So yeah, I think there's a lot of reasons for hope and a lot of reasons to make the transition as quickly as we can.
Yeah, I want to reflect on the questions that basically the set of presentations and the scope of this event has covered. And I think we discussed a lot about the urgency of action to limit warming to 1.5 degrees, and also the urgency of acting on that matter to bring down near-term climate risks. And we've learned about the very severe effects of those. But we've also learned that it's not just a question of urgency, it's also a question of legacy. Because what we do now might define the shape of this planet for generations to come, for millennia, potentially up to millennia, when we look at questions like sea level rise. And the dimension of tipping points as being brought in brings us basically into a legacy space where, and this might still be a difficult sell to policymakers, but it's certainly clear that from this generation, what will stay for centuries and millennia to come are decisions that will shape questions like crossing tipping points for long-term sea level rise, for example. And I think that is a dimension that is extremely relevant and brings these very near-term and the very long-term together. And I thought this was a very interesting perspective that I took away. Thank you.
Well, I would just briefly say there is no substitute for robust knowledge, especially for tipping points. We've seen in the presentations tonight that there are many scenarios that keep us on the 1.5 degree pathway, but you've probably also sensed that these scenarios are quite fragile. The fragility is really associated with the fact that there could be surprises in the climate system. We know about the physical possibilities of such surprises. They have occurred in the past, and I think it's extremely important for the public and policymakers to get the best science on tipping points, irreversibilities, surprises in the climate system, and therefore I think it's really high time to commission a special report on these issues. IPCC would be the body that provides that knowledge, and it would also accelerate, as we've seen with the special report on extreme events, the related science, which is an investment into the next 10 to 15 years. Thank you.
Thank you. Thanks, everybody. And with that, I'd like to thank Ambassador, the presenters, and of course all of you participants for all of your questions and engagement with the panel. I'm definitely not going to try and summarize your points. I hope that you took note, and essentially my biggest takeaway is the bottom line from the science is that delay in this decade will, without any uncertainty, put 1.5 entirely out of reach and potential catastrophic, I say potential catastrophic, certain catastrophic impacts, and then potential crossing some thresholds, which we're already starting to see potentially underway. And then also looking at the silver lining with Working Group 3, I don't think I've ever met a scientist as quite optimistic as Carl sometimes, given that the point that the bottom line of Working Group 3 and our ability to potentially close the gap by 2030, but only if we actually do act on the decisions that we have made in Glasgow and prior, and hopefully everybody does come back to the table with increased ambition in their NDCs prior to COP27, and then also acting on the other components like phasing, hopefully out, but I know the language is down, of coal, and fossil fuel subsidies. I know that's not everything that's necessary, but it will certainly start to put us on the right track. Thank you very much. Ambassador, would you like to...
Just very also thank you, the audience, for listening, but for me it was a pleasure to listen. I'm really pleased to have been able to listen to it. And as you said, it's a combination of information that raises concern, but it is also motivating, because you see there are possibilities to do it right. There are still possibilities. I'm convinced that additional information, as you said, Thomas, about tipping points will even further strengthen our willingness to use that tools that are available. And I hope that such report will really make a difference for each of us, for the policymakers, to bring us on a safe pathway. Thank you very much, and yes.